Merkava 1. How Jews without experience created a tank capable of surviving any hit. Imagine a country the size of half the Moscow region, surrounded by enemies on all sides, with a museum collection from all over the world in its garages, instead of normal tanks. This was exactly the situation Israel found itself in by the mid-60s, and the way out of it seemed absolutely impossible. But the Jews did what even great powers could not. Without a single day of experience in tank building, they created a machine that changed all ideas about crew protection. This is the story of how despair gave birth to one of the most unusual combat vehicles of the 20th century. When the State of Israel was born in 1948, its tank forces were a pitiful sight. The first combat vehicles of the young army were the French Renault 35 and Hotchkiss 39. Light tanks that were obsolete even before the start of the Second World War. A little later, British Cromwells and American Shermans, obtained from literally everywhere, were added to this scrap metal. They were bought from arms dealers, bartered, and sometimes simply stolen from European warehouses. Suppliers were clutching their heads because each type of tank required its own spare parts, its own shells, and its own trained mechanics. It was not an army, but a mobile museum of armored vehicles. By the mid-50s, the Israelis received more modern French Mk.1, and by the 60s, the Israel Defense Forces had about 400 American M48 and roughly the same number of British Centurions. The tank park remained heterogeneous, and the military command perfectly understood that this could not continue. Israel needed one main tank, well-armed and excellently protected, which would cover all the needs of the army. Two ways to solve the problem were considered. First, to develop their own machine from scratch. Second, to buy ready-made tanks abroad. Given that Israel had never in its history built anything more complex than trucks, the second option seemed much more realistic. Negotiations began with the Germans, the French, and the British. The West German Leopard 1 turned out to be mobile, but its level of protection left much to be desired. For a country that is constantly at war, this was unacceptable. But the British chieftain truly interested the Israelis. In 1967, two chieftains arrived in Israel for comprehensive testing. The British could not have imagined what awaited their machines in the Negev desert. Israeli tankers drove the chieftains as if they were the last tanks on Earth. They jumped them over dunes, forced the stony beds of dried-up rivers, and did not turn off the engines for days in 40-degree heat. After a few months, both machines were so thoroughly destroyed that the British had to send two more tanks to continue the tests. By the autumn of 1968, these chieftains were also driven to near death. But the Israelis received all the necessary information. The Jews were ready to place a large order in Britain for chieftains with modifications for the conditions of the Middle Eastern theater of military operations. The Ministry of Defense of the United Kingdom was rubbing its hands. This was not just a sale of tanks. These were contracts for spare parts, tools, crew training, and technical support for years to come. British industrialists were already calculating the profit when the Foreign Office intervened. The British Foreign Office vetoed the deal, stating that Israel was not a sufficiently peaceful state for the supply of offensive weapons. This was a stab in the back. The Israelis were at a dead end. The Germans were out because of the insufficient protection of their equipment. After the Six-Day War, the French imposed an embargo on arms supplies to the region. The Americans were busy with Vietnam and were not eager to share their latest developments. Only one way out remained: to build the tank themselves. It sounded like madness. The development of a modern main battle tank is a task that took giants like the Soviet Union or the United States many years of work by huge design bureaus with colossal experience. Israel had neither experience nor time nor sufficient resources. But the Jews decided to take a risk because they simply had no other choice. The person responsible for the project was the one without whom no tank would have simply existed. Israel Tal was not a desk general, but a real combat officer with an incredible biography. While still very young, he fought against Rommel's Afrika Korps in North Africa as part of the British Army. He went through the entire Second World War, and after that participated in all the wars of the young Jewish state. By the time work on the new tank began, Tal commanded all the tank forces of Israel and enjoyed colossal authority among both the military and politicians. He was that rare type of person who knew not only how to fight, but also how to break through any bureaucratic walls. On June 6, 1970, the Israeli Ministries of Defense and Finance received the results of a study on the feasibility of creating their own tank. The document was prepared under the leadership of Tal and contained a detailed analysis of all possible options. The conclusions were unambiguous. Israel needed its own combat vehicle designed for the specific conditions of the Middle Eastern theater of military operations. Usually, such documents migrate between departments for months, overgrown with resolutions and amendments. But Tal was a persistent person in the best sense of the word. Already after 2 months, in August of the year 70, the project received a green light from the government. By the standards of any bureaucratic machine, this was an absolutely incredible speed. Tal formulated the requirements for the new tank personally, based on his own combat experience. The first and main condition was unprecedented crew protection. Not just good protection, but such that tankers would survive even if the armor was penetrated. Israel is a small country with a small population, and every trained tanker represented an enormous value. Losing a machine was bad, but losing a trained crew was a catastrophe. The second requirement was powerful armament, capable of hitting any existing enemy tanks. The third condition was the ability to operate effectively, specifically in the Middle Eastern theater of military operations, with its deserts, mountains, and stony plains. The fourth point was the ability to carry infantrymen or the wounded inside the machine, which was absolutely untypical for tanks. And finally, for all its protection, the tank should not turn into a slow, clumsy monster. The work was entrusted to the company Israel Military Industries, and thanks to Tal's authority, the firm received everything necessary for development. Despite the fact that the engineers and designers had no experience in creating tanks, the work moved with striking speed. Already in April 1971, less than a year after the start of work, a full-size wooden model of the future machine was ready. On this model, the general layout, the placement of the crew, and the main design solutions were worked out. The next stage was a metal model, and here the Israelis showed striking ingenuity. They assembled the hull from a literally sawn-up Centurion. They took the rear part of the British machine and converted it into the front part of the new tank. The turret was also borrowed from a Centurion. The resulting hybrid looked strange, but it allowed for checking the operation of various units and assemblies planned for use on serial machines. This was a typical Israeli approach, not to wait for ideal conditions, but to work with what is available, quickly and effectively. During the tests of the metal model, a serious problem was discovered. Initially, it was planned to place the driver behind the engine transmission compartment, but in this configuration, he had a too limited view. The driver simply did not see where he was going, which was completely unacceptable for a combat vehicle. Designers had to move the driver's workstation to the left side of the hull, roughly as was done on the Soviet Mk.1. This solution led to many other changes in the layout, but ultimately made the machine significantly more convenient to control. After refinements, 2 full-fledged prototypes were ordered. A situation typical for a young industry arose with the hulls. They had to be ordered abroad, since there were no enterprises in Israel itself capable of manufacturing such complex products. The hulls arrived on time, but there was a delay with the turrets. The Israelis decided to manufacture them independently and, naturally, did not meet the deadlines. The first prototype could not be kept without a turret, so a turret from an American M48 was temporarily installed on it. In such a somewhat comical form, the machine went for testing at the very end of 1974. The tests continued for almost a year and a half, until '76, and during this time, the prototypes went through all conceivable tests. They were driven through deserts and mountains, fired from and fired at, checking the operation of every unit in the harshest conditions. In parallel, in '76, preparations for serial production began, based on the second prototype with its own Israeli turret. But the path from prototype to serial machine turned out to be much more difficult than anyone could have imagined. The serial production of the new tank became a real test of strength for the Israeli industry. The military rightly insisted that the machine should consist of parts produced inside the country. Depending on foreign suppliers in conditions of a constant threat of war and possible embargoes was too risky. This meant that hundreds of Israeli firms had to master the production of the most complex units and assemblies that they had never worked with before. The assembly of the tanks was organized in a special workshop at the Tel HaShomer military base. And the first machines were literally assembled by hand, with constant fitting of parts to each other. On April 26, 1979, the first 4 serial tanks were handed over to the military. Almost 3 years from the start of serial production to the first batch is a huge period. But one should not be surprised by this. The Israelis were creating not just a tank, but an entire industry from scratch. In the same year, '79, the machine was officially adopted under the name Merkava Mk.1. The name came from the development program, and in translation from Hebrew meant chariot. By 1980, 80 combat vehicles had already entered the troops, and the production rate was constantly increased to 10 and sometimes more tanks per month. In total, from 230 to 300 machines of the first modification were produced. Now, it is worth understanding what this tank represented from a technical point of view, because the Merkava was a machine that was unique in many ways. The armored hull was welded, but the front part was cast. The thickness of the upper front detail was 60 millimeters, the lower 90 millimeters. The angles of inclination reached 65 degrees. The sides had a thickness of 50 millimeters and were additionally covered by screens and suspension elements, which also served as a kind of protection. The most unusual thing in the design was the location of the engine transmission compartment. Unlike the absolute majority of the world's tanks, where the engine is in the rear, on the Merkava it was placed in the front, in the frontal part of the hull. Such a layout was typical for armored personnel carriers and infantry fighting vehicles, but was extremely rare on tanks. Under a massive hinged lid on the right side of the upper frontal detail were the engine and transmission, combined into a single motor block. The Israelis chose this solution deliberately. The power plant served as additional protection for the crew. A shell that pierced the front of the hull would first have to go through the engine before reaching the people. But that's not all. On the sides of the engine compartment, the designers placed fuel tanks, which also performed a protective function. A projectile that pierced the armor would fall into a tank of fuel, then hit a 30-millimeter armored partition, and only after that could it reach the engine. It would seem that fuel near the place of a possible hit is madness, because diesel can flare up. But the Israelis provided an advanced automatic fire extinguishing system for that time, which suppressed ignition in fractions of a second. Behind the engine was another armored partition 35 millimeters thick, separating the power plant from the combat compartment. The driver was located to the left of the engine compartment in a separate armored capsule with a wall thickness of 35 millimeters. At his disposal were 3 observation devices that provided a satisfactory view. Such isolated placement of the driver increased his chances of survival, even with serious damage to the tank. The turret turned out to be of a very unusual shape. The Israelis tried to make it as compact as possible. Combat experience showed that the percentage of hits on the turret is very high, so the smaller the target, the better. The turret was cast with an armor thickness of only 65 millimeters, which was compensated for by its small size and complex shape, which contributed to the ricochet of shells. True, they had to pay for compactness with cramped conditions. The working conditions for the crew inside were far from comfortable. 3 crew members were located in the turret. To the right of the gun sat the gunner with a periscopic observation device and a sight with 8-fold magnification, equipped with a laser rangefinder. Behind the gunner was the commander's place with a panoramic sight of 20-fold magnification and 5 viewing devices. To the left of the gun was the loader, who was additionally responsible for maintaining the radio station. The turret had 2 hatches for the entry and exit of the crew. A very unusual element for a tank was a 60mm mortar mounted on the turret to the right. For most of the world's armies, this seemed like a strange excess, but the Israelis perfectly understood the specifics of their theater of military operations. With the help of the mortar, it was possible to drop a mine behind a dune or a stone ridge, hitting an enemy sheltered from the direct fire of the tank gun. Machine guns were also installed on the turret to fight infantry and air targets. The rear part of the hull deserves special attention. Remember Tao's requirements about the possibility of carrying infantry inside the tank. The designers fulfilled it. In the rear, there was a hatch to a special landing compartment where several infantrymen, stretchers with wounded, or various cargoes and ammunition could be placed. This was not a full-fledged landing section like on a BMP. The infantrymen sat there in rather cramped conditions, but the very possibility of evacuating the wounded under armor was invaluable. The main armament of the Merkava was the British 70-caliber 105mm gun, well known to tankers all over the world. More precisely, it was its American version M68, which the Israelis produced at home under license. The gun was proven and reliable. It was also on the West German Leopard 1s and many other tanks of the Western world. The ammunition load was 62 rounds, and its placement was thought out with special care. There were only 6 shells in the turret for immediate use. The rest were stored in the hull in special containers. 6 containers of 2 shells each, and another 11 stacks of 1. Such a dispersal of the ammunition load significantly reduced the likelihood of its detonation when the tank was hit, which again worked for the main idea of the machine, preserving the lives of the crew. The chassis of the Merkava caused surprise among specialists from all over the world. The fact is that the Israelis chose a spring suspension, which was a development of the ideas of the American designer Christie from the 30s. It would seem to be a strange decision. Since the Second World War, torsion bar suspension was considered advanced. It was on all modern tanks from the Soviet T-64 to the American Abrams. Even on the legendary T-34, the Christie suspension was already considered not fully satisfactory. And in '41, designers planned a transition to torsion bars. But the Israelis did not follow tank fashion, but created a machine for specific operating conditions. On the stony soils of the Middle East, where tanks had to jump over boulders of a solid size, spring suspension turned out to be more suitable. It was heavier than a torsion bar one, but it provided better smoothness on rough terrain and, importantly, was easily repaired in the field. The suspension elements were located outside the armored hull and, if damaged, were replaced by the crew in just a few hours. With a torsion bar suspension that passes inside the hull, such a trick would not work. Factory conditions were required for its repair. In addition, the external elements of the suspension created additional protection for the sides against heat shells. On each side, there were 6 road wheels and 4 support rollers. The wheels initially had rubber tires, although they were later abandoned. At a tank weight of 61 tons, the rubber simply could not withstand the loads and was quickly destroyed. Hydraulic shock absorbers were on the front and rear suspension units for better damping of vibrations. The drive wheels with 2 sprockets were located in the front and idler wheels in the rear. The tracks were 640 millimeters wide, with 110 links in each. The heart of the tank was the American diesel engine, AVDS 1796, well mastered in the Israeli troops. The same engines were on Centurions and M48. For the Merkava, the engine was boosted to 900 horsepower and connected to an American hydromechanical transmission. These were not the most outstanding characteristics for a machine weighing over 60 tons. But the Israelis prioritized reliability and maintainability over the pursuit of speed records. The combat baptism of the Merkava took place in June 1982, when Israel invaded Lebanon. The operation was called Peace for Galilee, and about 1,200 tanks were concentrated on the border for it. Of these, approximately 200 were brand new Merkavas, which were to show themselves in real combat for the first time. The Israelis were opposed by militants of the Palestine Liberation Organization and units of the Syrian army armed with Soviet equipment, T-55, T-62, and even T-34-85 veterans. The Syrians also had a certain number of T-72, modern at that time. On June 6th, Israeli troops with powerful air support crossed the border and moved deep into Lebanese territory. Fierce battles unfolded. Merkavas operated in the hottest spots, stormed fortified positions in urban areas, and fought on mountain roads and in valleys. Tankers had to resist not only enemy armored vehicles, but also infantry with anti-tank weapons. And the conditions of the Middle Eastern theater of operations did not forgive mistakes. By the end of the active phase of the fighting, the Israeli army had lost 52 machines of various types irrevocably. The statistics for the Merkavas turned out to be indicative. Only 7 tanks of this type were lost irrevocably. Another 27 machines received damage of varying degrees of severity, but were restored. Among the Merkava crews, there were no dead tankers at all, 0 people. For comparison, among the crews of other tanks, losses were significant. Tal's concept of the priority of crew protection was fully confirmed in battle. Even when the armor was pierced, even with heavy damage to the machine, the people inside remained alive thanks to the thoughtful placement of the engine, fuel tanks, and armored partitions. After the Lebanon War, many stories appeared in military journals and on the pages of specialized publications about how Merkavas allegedly snapped Soviet tanks like nuts. Especially savored were stories about the destruction of the T-72, the latest at that time, which were considered the pride of Soviet tank building. These stories quickly turned into a legend that lovers of military equipment all over the world still recount. However, the reality turned out to be much more prosaic. The fact is that there were simply no direct tank duels between Merkavas and T-72s in that war. All Syrian tanks of this type lost during the conflict were destroyed not by Israeli tankers, but by crews of TOW anti-tank missile systems. The combined armor that appeared on Soviet machines, starting with the T-64, was developed specifically for protection against heat ammunition and coped quite successfully with this task. The Israelis had the M111 sub-caliber projectile, which, according to their statements, could pierce the frontal armor of the T-72 from a distance of 1.5 kilometers. But it was not possible to verify these claims in practice in '82. One should also honestly admit the shortcomings of the first Merkava, of which there were enough, primarily the dimensions of the machine. The tank turned out to be very large, which made it a noticeable target on the battlefield. Compared to the low silhouettes of Soviet machines, the Israeli chariot looked like a real giant. Large size meant a high probability of being hit, and no armor could fully compensate for this. The second serious problem was the armament. 105 millimeters is a caliber that the world began to abandon in the late 70s. Western countries were moving to 120 millimeter caliber guns. The Soviet Union had switched from 115 to 125 millimeters even earlier. The Israeli gun was gradually becoming obsolete, and its capabilities might not be enough against promising enemy tanks with reinforced armor. Designers would fix this problem only on the third modification of the machine by installing a 120 millimeter caliber gun. The third minus concerned the general armor protection of the hull. While the crew protection was brilliantly thought out, the general armor resistance of the tank left much to be desired. 65 millimeters on the turret and 60 on the upper frontal detail are rather modest figures for a machine of this class. After the first real battles, they began to strengthen the armor by hanging additional screens and dynamic protection blocks. It is curious to compare the Merkava with the American Abrams, which was developed around the same years. The American tank weighed less, had significantly more serious armor protection with the use of composite materials, and a classic layout with a rear location of the power plant. At the same time, it never even occurred to the Americans to build some kind of landing compartment inside their tank. They were creating a pure combat machine without compromises. In essence, the Merkava represented something between a tank and a heavy infantry fighting vehicle with a tank turret and a tank gun. It was a machine tailored to the specific conditions of Israeli wars. And comparing it with tanks of other countries directly would not be entirely correct. The Israelis perfectly understood the shortcomings of their firstborn and worked on it continuously. Already when the first Merkavas were coming off the assembly line, the designers were working on an improved version. The experience of the Lebanon War gave invaluable information about what needed to be improved. The second modification of the chariot received significantly reinforced armor, and machines of the first series began to be pulled up to its level. Tanks returned to the factory, where additional protection was mounted on them, and observation and aiming systems were improved. The Merkava evolved right before one's eyes, turning from an unusual experiment into a truly formidable combat machine. 61 tons of metal, created by people without experience in tank building, proved the main thing. Crew protection can and should be a priority. No other tank in the world at that time could boast such survival of the people inside. 0 dead tankers in the Merkava crews during the Lebanon campaign. This was an argument that outweighed any criticism. The Israelis created not just a tank, but a philosophy of tank building, where the machine exists for the sake of the people, and not the people for the sake of the machine. The first Merkava became the foundation for an entire family of combat vehicles that still form the basis of the Israeli armored forces. From a strange hybrid assembled on a knee from a sawn Centurion, one of the most recognizable and discussed machines in world tank building grew. And it all started with the fact that a small country was refused the sale of tanks, and it decided to build its own.